In this review video, we are going to talk about complex numbers. Complex numbers are written as a plus bi, where a represents the real number and bi represents the pure imaginary number. Now, notice again that the imaginary unit has to be I. It cannot be an I square. It cannot be an I to the third power. So if you run across any exponents attached to your imaginary unit that's bigger than 1, you have got to use the methods that we discussed in the previous review about imaginary units to simplify those. And we'll run across a few, so I'll show you what I'm talking about when we get there. So we're going to talk about addition and subtraction, combined, which you will just basically combine like terms. Multiplication, you can distribute, or you might even have to FOIL and then combine like terms in order to simplify those. And then division, you will have to multiply by I or the conjugate to rationalize the denominator. And we'll talk a little bit more about that when we get there. Now, this video may be a little bit longer than others because we do have 12 examples that I want to go through just to review you on operations with complex numbers. So the first two examples, take an a plus bi and add it to another complex a plus bi. So what your thought process should be is you add up your a values. So you should be thinking 6 plus negative 8. That gives me negative 2. You should be thinking, to add up your bi numbers, you should be thinking negative 4i plus 6i, and that gives me positive 2i. When you add two complex numbers, you get a complex number out. Now, is it okay for your a value to end up being 0? Absolutely. Is it okay for your bi value to end up being 0i? Yes. But you don't write 0 in your final answer. So sometimes you just have an a value, and sometimes you just have a bi value as an answer, and that is okay. In the second example, number 11, we're going to do the same thing. So negative 3 minus 4 gives me negative 7, and 5i minus 6i gives me negative I, and that is my final answer. In number 3, you can clearly see that looks like a distributive problem, so we're going to distribute. 4i times negative 8 is negative 32i, but watch what happens when you multiply a 4i times the 5i, you get 20i squared. Now, I mentioned earlier that you cannot have anything bigger than an I, so we're going to have to simplify this part right here. Well, if you go back, if you watch the previous review for imaginary units, you know that every I square is equivalent to negative 1. So I have negative 20 times negative 1, which is negative 20. So my final answer would be negative 20 minus 32i. Now, all of your answers should be written in proper format, a plus bi. So my a value of negative 20 goes first, and my bi value goes last. That is proper formatting for complex numbers. Number 13 adds both skills. We will distribute first, and then we will combine like terms. So in the first parentheses, we're going to distribute the 6, so that would be 18 plus 12i. In the second group, we're going to distribute the negative I, which gives me negative 5i plus 7i squared. Now, I have to simplify my 7i squared. So 7 times negative 1 is negative 7. So I'm going to take that out and put negative 7 in its place. Now I go through and I combine my terms. I add up my a values, 18 minus 7 equals 11, and I add up my bi values, which is 12 minus 5i, which is positive 7i. Notice that my final answer is written in proper form, a plus bi. That's very important. For example, number 14 and 15 and 16 and 17, we are going to have to FOIL. So in the first example, Number 14, we're going to completely FOIL. So 5 times 9 is 45. 5 times negative 8i is negative 40i. 3i times 9i is positive 27i. And 3i times negative 8i is negative 24i squared. So please make sure you don't lose that I squared. Now, I do need to simplify this. So negative 24i squared becomes plus 24. Because remember, every I squared is equivalent to a negative 1. Now I'm going to go through and add up my i's. 45 and 24 give me 69. Negative 40i plus 27i gives me negative 13i. I have a final answer in complex form, a plus bi. Now, number 15, this is special, and we will need this when we get into division in just a few minutes. These are conjugates. You have a plus bi times an a minus bi. When you multiply complex conjugates together, you get just a number. You only get an a value, okay? So when I full out FOIL this, 5 times 5 is 25. 5 times negative 3i is negative 15i, which will cancel with 3i times 5, positive 15i. And then when I multiply the last ones together, I get negative 9i squared. Now, negative 9 times negative 1 produces a positive 9. So my 25 plus 9 is 34. My 15 i's cancel because they are opposites. So this time I only get an a value as a final answer. Number 16, when you take a binomial and you square it, you have to write it down twice, and then you have to FOIL it. You cannot just square both terms in that parentheses. You're going to have to write it down twice exactly as it is and FOIL it out. So 3 times 3 is 9. 3 times negative 11 is negative 33i. Negative 11i times 3 is also another negative 33i, which I will combine together in just a minute. And when I multiply negative 11i times itself, I get positive 121i squared. Now, 121i squared, that becomes negative 121, because 121 times negative 1, because I squared is a negative 1, becomes negative 121. So I end up with 9 minus 121, which is my a value, and I end up with negative 66i as my b value. Number 17, we have a FOIL scenario and a distribute scenario. So we're going to FOIL first. 7 times 6 is 42. 7 times negative I is negative 7i. Negative 2i times 6 is negative 12i. Negative 2i times negative I is positive 2i squared. We will clean that up in just a minute. I'm going to go ahead and distribute the 3 in the second parentheses, or the second group. So 3 times 9 is positive 27, and 3 times negative 5i is negative 15i. So right now, the only thing I need to change is that becomes a negative 2, because 2 times negative 1, which is an I squared, becomes a negative 2. So I go through and I add up all my a values. So 42 minus 2 plus 27 is 67, and negative 7i, negative 12i, and negative 15i all add up to negative 34i. So I add up all my a's and add up all my bi's for a total of 67 minus 34i. Now, when it comes to division, we have two types of division problems, if you notice. Number 18 and 19 both have monomial denominators, but 20 and 21 have binomial denominators. So how you deal with that is different. In 18 and 19, I need to make sure that I can get an even power of I so that I can break it up to either a 1 or a -1. So in number 18, if I multiply the top and the bottom by just simply I over I, that gives me 6I over 7I squared, and that would become 6I over -7. You can write that as negative 6I over 7. You can pull that negative from the denominator and just stick it out in front of that fraction. In number 19, I'm going to do the same thing. I need to get the I out of the denominator. That's called rationalizing. I apologize, I did not mention it in number 18. You do have to eliminate all the i's in denominators, just like you have to eliminate all radicals in denominators. So we are rationalizing these denominators. So I'm going to multiply by I over I. Across the top, I have to distribute. So that is 26I plus 4I squared all over 8I squared. Now, I can break down both of those I squares. So that would be, first thing I'm going to do, -4 plus 26I, because remember it has to be an A plus BI format, over -8. 8I squared becomes -8. And then I can simplify all of the numbers in this problem because they are all divisible by 2. But not only am I going to divide them by 2, remember I mentioned early in a previous review session that you cannot leave negative denominators. So we're going to divide by -2. So that would be +2 minus 13I over 4. Now, some professors will take that answer and some people will want it broken down further because 2 minus 13I over 4 is not in proper A plus BI format. So to take that one step further, we would have to separate 2 over 4, which will reduce, minus 13I over 4. So in a true A plus BI format, we would have 1/2 minus 13 over 4I. That is a true A plus BI format. Now, I will take either answer. I will take it left as a complete fraction, or I will take those answers in the A plus BI format. I would get into a habit of writing the second answer, 1/2 minus 13I or 13 over 4I, because that is true complex format. Now, in the final two examples, notice that we have complex denominators. So our binomial or complex denominators that are binomials. So what we're going to have to do is multiply by the conjugate. Now remember, I mentioned earlier in a previous example that when you multiply complex conjugates together, you get just a number or you get just an A value. So the only way to rationalize a binomial complex denominator is to multiply by its conjugate. So across the numerators, I'm going to distribute. That is going to give me 2I plus 6I squared. Across the bottom, I'm going to have to completely FOIL. 2 times 2 is 4. 2 times 6I is positive 12I. It will cancel with the negative 12I I get next. And then I finally get negative 36I squared. Now, I have 2 I squares that I need to clean up. I have an I square in the numerator, so that gives me -6 plus 2I. That's my A plus BI. The number, the A value I get is my denominator. Since the 12 i's cancel, this becomes a positive 36, so I get a denominator of 40. 4 plus 36 is 40. Now, I do need to simplify that, so what I would recommend is you go ahead and break it up into -6 over 40, which is your A value, plus 2 over 40I, which is your B value. Now, when you reduce that, you get -3 over 20 plus 1 over 20I. I highly recommend that all final answers be written as A plus BI, a true complex number. Number 21 takes a little more time because when we multiply the numerator and the denominator, by the complex conjugate of the denominator, we end up having to FOIL both the numerator and the denominator. Now, our numerator should end up as an a plus bi numerator, and our denominator will end up with just an a value. So when I completely FOIL across the top, negative 5 times 1, negative 5 times positive 3i, 5i times 1, and 5i times 3i, which is positive 15i squared, which I will clean up in just a minute. I'm going to go ahead and multiply out the complex conjugates in the bottom. 1 times 1 is 1. 1 times 3i, which will cancel with the negative 3i I get next. And then I get negative 9i squared in the denominator. So I have two I squares that have to be corrected. So this becomes negative 15. This becomes positive 9. So negative 5 times negative 15 or plus negative 15 is negative 20. When I add my BI values, I get negative 10i. Across the bottom, the 3 i's will cancel, and 1 plus 9 is 10. So when I try to write this in true form, I get negative 20 over 10. That's my a value, which I will reduce. Negative 10i over 10. So my final answer would be negative 2 minus I. That is true complex form. I know this was kind of fast, but if you have any questions, do not hesitate to contact me.